Pi. It's simple enough. Just the ratio of the circumference of a circle to its diameter. Although this concept is pretty easy to understand, how to go about calculating it stumped mathematicians for thousands of years. During this video, I'm going to be talking quite fast, so start listening. Almost 4,000 years ago, the Babylonians and Egyptians were the first people to approximate pi. It is unclear what their exact method was, but we do know that their end product was 3.125. Later on, and much more accurately, an Egyptian scribe is quoted as saying, "If you cut off 1/9 of a diameter and construct a square upon the remainder, this has the same area as the circle." In much simpler terms, he said that pi was equal to the square of 8 divided by 9 times 4, which is equal to approximately 3.16049. Despite the Egyptians estimating pi close to accurately, the Chinese estimated pi as 3, while others continued advancing. If only there was Twitter back then, maybe they would have heard the news. Anyways, in the Old Testament, which was written in the 6th century BC, stated, quote, "Also, he made a molten sea of 10 cubits from brim to brim, round in the compass, and 5 cubits the height thereof, and a line of 30 cubits did compass it round about." Gosh, that was a long sentence. Now bear with me. When scientists and mathematicians translated this, they missed out on a letter. This error resulted in the equation being misinterpreted as pi divided by 3 is equal to 106 divided by 106. Due to this, some still think that the Old Testament stated that pi was equal to 3. Despite this, with the correct translation, the equation stated that pi divided by 3 is equal to 111 divided by 106, which results in pi being equal to 3.1415094, which is incredibly accurate for its day and age. For this next part of the video, you need to know what circumscribe and inscribe mean. According to Lord Google, circumscribe means to draw a figure around another, touching it at all points but not cutting it. Also according to Google, inscribe means to draw a figure within another so that their boundaries touch but do not intersect. Anyways, let's continue on with the video. The Greeks helped advance pi by finding ways to calculate it, which would be used as a base idea for more successful methods. First off, Bryson of Heraclea calculated pi by calculating the area of polygons, inscribing and circumscribing a circle. He only managed to calculate a few digits because his method of finding the polygon's areas proved to be too complicated to be efficient. Archimedes of Syracuse, who is also Greek, took inspiration to Bryson's method of calculating pi, but decided to use the polygon's perimeters rather than their areas. He ultimately ended with two 96-sided polygons and found that pi was equal to 22 divided by 7. At this point in time, there was a pause in pi development. The pause ended when China finally caught up in 263 AD, when Liu Hui found Archimedes' method on his own. Using polygons with up to 192 sides, he calculated the first 5 accurate digits of pi, 3.14159. In the 5th century, Zhu Changqi and his son Zhu Gangqi used polygons with up to 24,576 sides to calculate pi. Let's take a moment to think about that. 24,576 sides. That's almost microscopic. Anyways, they came up with one of the most accurate estimates yet. The pi is between 3.1415926 and 3.1415967, which is completely accurate. After this, Brahmagupta, no, I am not making up these names, calculated the perimeters of inscribed polygons, much like most of the other mathematicians. The difference here is that based on his results, he guessed that pi would be equal to the square root of 10, which is equal to about 3.162. We now know that this is incorrect, but at the time it was widely accepted by the Arabs, possibly because the square root of 10 is easy to remember. Here we experienced another break. In the 16th century, there was an explosion of pi-related discoveries. Francois Viet used Archimedes' method to find that pi was between 3.141592635 and 3.141592637. To accomplish this, he used a polygon with 393,216 sides. Despite this accomplishment, he will be remembered better as the first person in history to describe pi using an infinite product. His formula is pretty hard to explain, so I'll just put it on the screen. Since his formula was so complicated, he didn't even use it when he calculated pi. You know your formula is bad when you don't even use it. Its main purpose was to inspire new formulas like it. Later, in 1593, Adrianus Romanus was able to find pi to the 17th digit, although only 15 were correct. 3 years later, in 1596, German Ludolf van Swellen found 20 digits using the Archimedes method. When he died in 1610, he found 35 correct digits and had them engraved on his tombstone. You know someone's a dedicated mathematician when they have pi engraved on their tombstone. There had not yet been a symbol to represent pi, which changed in 1647 when William Oughtred began using parenthesis/parenthesis to represent pi. 3 years later, in 1650, John Wallis came up with the formula as shown on screen. It was described as complicated as well as remarkable. Wallis then showed his formula to Lord Brouncker, who came up with another formula, as shown on screen. In 1682, Gottfried Leibniz discovered that the tangent of pi divided by 4 is equal to 1. He used this to create the formula on screen. The problem with this formula is that to calculate 4 decimal places, 10,000 terms are required. 24 years later, in 1706, John Machin made an extremely important discovery. He found yet another equation shown on screen, which is easier to calculate than all the other equations up to this point. Note, the easy is defined by genius mathematicians. Anyways, William Shanks used this formula to calculate 707 digits of pi. Sadly, later in 1945, it was discovered that only 527 of the digits were correct. Imagine feeling so proud that your life work was complete, only to have it proved wrong. Luckily for him, he never knew that any of his calculations were incorrect. In 1767, Johann Heinrich Lambert proved that pi was irrational. He reasoned that the tangent of a rational number cannot be a rational number, and since the tangent of pi divided by 4 is equal to 1, pi could not be a rational number. After this discovery, there were no more major events involving pi. Now, in the 20th century, computers have taken over the pi world. At the time in which this video is made, the current record holder has found the first 10 trillion digits of pi.